Domain and range of transform functions. So remember, domain is the possible x values, and range is the possible y values. You have to remember that. There is no other way to remember that other than domain and range. Domain goes with x, range goes with y. The way I kind of try to get people to remember is rain, like the rain falls from the sky. It goes up and down. So rain goes this way, goes down. So range goes with the y-axis or the y values. That's really the only trick I can think of to remind you. So I'm going to graph the parent function of y equals x squared and then talk about the domain and range. So since there is no value in front of x squared, you know the a value is 1. Since there's not a number inside of the parentheses adding to x, then it doesn't move left or right. And since there's no number adding at the end, you don't move it up or down. So your parent function is at the vertex is at the origin. And then since the a value is 1, you would move up 1 over 1 each time, each direction. So that is the parent function. So if we talk about x values, remember x values go with the domain goes with the x values. So I'm looking this direction. So if you look over here at negative 1, 2, 3, 4, 5, 6, there is no value showing, but remember this is an arrow and this would continue. So eventually I would hit negative 6. So there are negative values. There are also any positive values. So the x is all real numbers. You can also write it in interval notation and say it goes from negative infinity to positive infinity. I personally like interval notation way more than writing it out, but that's just my opinion. It's the same thing. The only reason you would have to use one over the other is if it was like a multiple choice question and it only used either all real numbers or it used interval notation. Okay, so now let's look at the y values. So if you look at the y values, there are definitely not any values below 0, but there are definitely values above 0 and they go all the way to infinity. So then for range, or for y values, you would say y is greater than or equal to 0, or it goes from 0 to positive infinity. Remember, on interval notation, if 0 is included, which this one is, you would have to write it as a bracket. Sorry. So make sure you write it as a bracket saying that 0 is included and it goes to infinity. And then this one, so notice, and let me write out domain just to make sure we have it. So domain is the x values. They're all real numbers. It goes from negative infinity to positive infinity. Range, or the y values, are all greater than 0 or from 0 to positive infinity. Okay, so that's the parent function. Now let's do another one. Y equals, parentheses, x minus 3 squared plus 2. Okay, move the vertex. So negative 3, x minus 3. If it's a negative 3, then I know I need to move the opposite direction because h is always opposite. So 1, 2, 3. And then the k value is positive 2, so 1, 2. So that is my vertex. Now if you notice, again, there's no number in front of the parentheses, so it's just 1. So I'm going to move over 1, up 1, over 1, up 1. So that would be my transformed function. Let's look at the domain. The domain of this function, it looks like it stops there, but remember those arrows are important. It would keep going and going and going and going and going. So it actually is any negative number and any positive number. Like if I look along this and I kept continuing, I could eventually get to negative 100. Or on this side, I could eventually get to positive 100. So you would say it goes from negative infinity to positive infinity. Or you could say all real numbers. Okay, now let's do the range. So since this one was shifted up 2 units from the x-axis or from the origin, it was shifted up 2. Instead of it starting at 0 like this one did, it's going to start at 2. So it would go from 2 to positive infinity. So notice it starts at 2, this is the lowest, and then it goes up from there. So it would go from 2 to positive infinity, or y is greater than 2 if you wanted to write it in as an inequality. Y is greater than or equal to 2. Okay, so that's that equation. Now I want to do one that has a negative a value so that you can see what happens when it flips over. So we have the equation y equals negative 1/2 x plus 1 squared minus 2. Okay, remember always move the vertex first. So I have a 1 as my h value and negative 2 as my k. So I need to move left 1 and down 2. Okay, and then my a value, notice, remember a is in front of the parentheses or in front of x. So my a value is negative 1/2. So I'm going to move over 1, you always move over 1, and then down half of a unit. Move over 1, down half of a unit. So that would be my transformed function. Notice it's upside down because the a is negative. Now let's do our domain. So domain, notice this direction, every number can be included because this could keep going. Every number could be included because this could keep going. So it is negative infinity to positive infinity, or all real numbers. And then the range, if you look, this is where it starts, and then which direction does it go? It goes down. So it would start at negative 2 and go to, no, I'm sorry, I'm writing that backwards. Negative 2 is the largest number. Negative 2 is the largest number, so you would actually write it as from negative infinity to negative 2. You don't want to write it the other direction because then it would say, like you would read it as negative 2 is greater than negative infinity. So you always have to write the smaller number first. So negative infinity is smaller than negative 2, so that's how you would write it. Or you could say y is less than or equal to negative 2, because all of the y values are less than negative 2.